All right, in this video, we are going to show another example of solving a rational equation or an equation with fractions in it. And this is our second example. In the first example, we only had numbers in the denominators. Okay. In this equation, you can see that we have a variable in the denominator. We're going to, in our class, we're not going to look at ones that are very complicated. So I'm going to this example is going to be a very simple one. So we're going to go through this example, and then I'm going to show you in the next video about something that you need to be careful about whenever you solve equations with fractions in them. Okay, so let's solve this one out. So we know from the previous video that the general strategy, right, is to multiply through the equation by the LCD, right, to get rid of the fractions. So what we're going to do is to look at these denominators and figure out what the LCD is going to be. All right, so in this case, how I like to do it is just look at the numbers first. The numbers here, this is a 1, so that doesn't really factor into it. You don't really need to worry about that. Here I have a 3 and a 6, right? And so we would starting with the bigger number, right? 6, 3 already goes into 6. And so the smallest number that both 3 and 6 can go into, the smallest integer is 6, okay? So LCD is going to have a 6 for the number part here. And now it is also going to have an x in it because this denominator has an x in it as well. So the examples that we'll look at in this section, finding the LCD is not going to be super complicated when it comes to anything really. It can be difficult, all right? So if you're watching this video for a more complicated rational expression problem where you have to factor the denominator, we're not going to talk about that in this video. Okay. All right. So there's our LCD. It's just 6x. Okay. And that's it. And so what we'll need to do then is to multiply both sides, right, of this equation by the LCD. All right. So the left side, since it has two terms, I am going to put those in parentheses, right? So I do not forget to distribute this to both sides, to both terms. Over on the right hand side, there's only one term, so I'm not going to worry about that as much. All right, and so over here on the left hand side, I am going to distribute that 6x to both terms. So I have 6x times 1 over x plus 6x times 1/3. All right. And in fact, sometimes people, you'll see people just do it this way, right? They'll just go ahead and multiply each term by the LCD. Over on the right-hand side, I don't need to do any distributing at all. I can go ahead and start canceling this out, right? And remember, what's supposed to happen is that these fractions are supposed to go away after you cancel things out, right? So I can see I have a 6 on the bottom part here, and I have a 6x over here. Sometimes people get confused about where the 6x should be. And remember, if you get confused about that, you can always write this as being over 1, right? Because anything divided by 1 is itself. So 6x is the same as 6x over 1, right? And now I can see I have a common factor, right, in the numerator and denominator. 6 goes into 6 up here, so I can do some canceling. 6 goes into itself once, and it goes into 6 one time. All right? So what I will have on top is a 5x. On the bottom, right, I have 1 times 1. So this would be like 5x over 1, but I am not going to write that, right? Because again, anything divided by 1 is itself. So this all works out to be just 5x, okay? All right, I'm going to keep canceling. Again, this 6x over here on the left side, you can think of that as 6x over 1. And you can see I have an x on the bottom and an x on the top. And so I'm going to cancel that out. And that leaves me with 6 times 1 over 1 times 1. right? X goes into itself once, it goes into X once again. So this just comes out to be a 6 over here. All right, here I have a 3 on the bottom and a 6 on the top. So 3 goes into itself one time. 3 goes into 6 two times. All right, so I have 2x times 1. That's going to be 2x over 1, which I'm not going to write. And so that's what I wind up with. So you can see what happened was all of the fractions canceled out. And that's the purpose of multiplying through by the LCD. It makes it into a problem that is simpler than the one that you started with. Okay. So, and then we would just solve this out. Okay. So subtract 2x from both sides. Using the addition principle, so that will give us a 6 over on this side, and on the right hand side 5x minus 2x gives me 3x, right? That's the addition principle that we're using. That gets every term with an x on one side, every term without an x on the other side. Next up, divide both sides by 3. 6 divided by 3 is 2, so I get x equals 2. Okay, so that's our solution over here. All right, so you do have to be a little bit careful here, and we will talk more about this in the next video. Okay, but remember, one of the rules, and the two rules that we're going by, the addition principle and the multiplication principle. The multiplication principle says, hey, you can multiply both sides of an equation by any number you like, except for 0. You can't multiply both sides by 0. So over here, right, when we multiply through by the LCD had a variable in it, right? And so we have what can end up happening is that when you multiply through the equation by both sides of an equation by an expression that has a variable in here, we don't know if that's 0 or not, because we really only know what x is until we get to the end of the problem, right? So what can happen is that you multiply through by the LCD and you accidentally multiply through by 0 and you didn't even know it because it had a variable in it. So you have to be extremely careful about that. So that's not that didn't happen in this case, right? In this case, when we look, the LCD was 6x. At the end of the problem, right, we know that 6x, we now know that x is 2, right? So if we plug a 2 in for x, we know that that was 12, okay? We didn't know it at the time because we didn't know what x was, right? But what we did here is okay. We multiply through by a non-zero number. So the thing that you have to remember, right, with these is that anytime you multiply through by an LCD that has a variable in it, you're going to have to go back and check to make sure that doesn't make that solution, in this case 2, doesn't make the LCD equal to 0. If it does make the LCD equal to 0, then you need to throw that solution out. Okay, so what happens there is if it does make the LCD 0, you've violated the multiplication rule. Okay, and when you violate that, that means that an extra solution kind of crept in that wasn't really a solution of the original, right? Another way that you can check these solutions is you can go back and plug them into the original equation, right? And check to see if they work, okay? So that is also a more thorough check actually than just checking it into the LCD. All right, we will talk more about this situation with the LCD in the next video.